All right, let's go ahead and jump in. So what the heck is spatial data? Spatial data is this large, giant, fluffy definition. And I will say this, spatial data or geospatial data has been around as long as maps have been around. I'm going to be focusing on the concept of spatial data as the data type inside of SQL Server. There are a lot of, there definitely are a lot of overlapping in the general terms of spatial, but I'm mostly going to be focused on it as the data type inside of SQL Server. So this is the giant fluffy definition, and this is my definition. I'm a very bullet points, get to the point kind of a gal. My definition is the laying out of shapes on a map, and notice the map is in quotes. The reason the map is in quotes is because of this. This is, when you think of a map, this is probably something that more than likely comes to mind. This is, there are a lot of the various power fill-in-the-blank tools that Microsoft has shown. And we've seen a lot of those maps. This is an example of one. This is actually, I wish you guys could talk. I was going to say, anybody have any guesses as to what this data represents? This data is beer data. These are the microbreweries. I'm from Indianapolis. So this is actually the microbreweries in Indiana laid out on a map using spatial data. So, but this is the typical example. Here's another example using one of those power tools. This is another view, an expanded view of, again, beer data, and this is a heat map from Power Map. So I will give the caveat right now. All of those Power View and Power Map, they do not yet. I'm hopeful on the yet part. I hope they do. They do not inherently support spatial data. So this heat map using Power Map is actually taking a step back from the spatial data, and it's using latitude and longitude to produce this map. So I will go ahead and say that unfortunately at this time, all of the power fill-in-the-blank tools do not inherently support spatial data, but they're getting closer, and I'll show you guys at the end a little bit of how they're working their way towards that. So, okay, this is another typical example that comes to mind, but this is where I'm going to focus today, where a lot of people typically haven't seen this aspect of spatial data used within SQL Server. This here is actually a floor plan of a hotel, and this is actually just a snippet from Management Studio that's returning that spatial data. You can do a lot of those kinds of things with spatial data as well. So, but this is also a map. It's just a different flavor of a map as well. So, here's another example of a floor plan. Returning results from within SQL Server. So, so not the typical thought of map, but also this is also a map. So, okay. So when you're talking about spatial data, it comes in two different flavors. There is the geometry data type and the geography data type. So the geometry data type, if you're dealing with a flat plane, then geometry is suitable for your selection of your data type of your spatial data. If you need to account for the curvature of the Earth, then you're going to want to select geography. And people are like, what's the difference and why does that matter? Here's a typical example I use when I explain the differences. So on the left is the flat map, and on the right is the round Earth map. So if you have a, say for example, a flight that travels from the West Coast over to Europe, on a flat map it looks like this. In actuality, when you take into account the curvature of the Earth, you can see the flight paths are much different, and those that can be very important when you're tracking planes to know where their paths are. So this is kind of a helpful example. Anytime you're dealing with like if you're dealing with addresses, something that relates to an address, you're going to want to use the geography data type. Okay, so in spatial data, you do a lot of grid laying out of things on a grid. You know, back in grade school, they give you the graphs paper. You have what's called the X and the Y axis, and you map that out. So this example here shows kind of how you used to do it back in school. So the first number here is your x-axis, and then the second number is your y. So you go over on the x and up on the y. Spatial data does that as well, and you can see over here on the right a point, which is a shape inside of spatial data, is dictated by spaces. So the first point is the x-axis is 3 space and then 4 on the y-axis. You also can have multiple points. So a line string, for example, this would be the first point and then the second point. So the commas come into play with spatial data when you're dealing with multiple points. So just a little refresher. We haven't done that for a while, so I'm sure. So, okay. The other concept I want to go over is shapes. And this is the thing that really kind of threw me when I started reading about spatial data. I'm like, why on earth would I want to store a shape in my database? Betty from accounting has never came to me and asked, here, put this shape into a database. It was just a foreign concept. But I will show you the power of those shapes when we get into the demo portion. So we kind of talked about the points already, x, y axis. You can also have z and m coordinates as well. So z is elevation, m is for measure. The m, that one is flexible. It can be anything you want it to be that can be stored as a number. One of the examples that I've seen that kind of made more sense to me was like mile markers. You know, if I have a point, you know, on a if I'm dealing with points, I can potentially store the mile marker where that would be if it relates to a road or something. But it's flexible. It can be used in any way that makes sense for the points that you have. Line strings. We saw a line string. It's just